Hi, my name is Dylan Zeller, and today I'm going to talk to you about non-deterministic finite automation and deterministic finite automation for regular expressions, specifically this pattern you see on the screen. So let's start with what a regular expression is. So it's a special string used to describe a pattern. It's used to find patterns that are more general than one instance. For example, if you want to find a bunch of email addresses in a document, this is a common pattern that's used to find any email that's valid, meaning it only uses characters A through Z with certain other symbols and 0 through 9. There are three main types of symbols in a regular expression. So the first of which is a single character. So say I had this lowercase x as part of my regular expression. That means that that symbol would only match a lowercase x. Next we have special characters. Each of these special characters has its own meaning, some of which will anchor to the front of a word, anchor to the end of a word, or tell you you only have to have so many of a certain single character. For example, the Klein star, which we'll be looking at today, means that you can have 0 or many instances of pattern. That means you can have 0 x's, or 5 x's, or 1,000 x's, and it'll still work. So non-deterministic finite automation can be described by a 5-tuple, which has these 5 parameters. The first of which is Q, which represents all possible states of the machine. The next sigma represents the symbols known as the alphabet, whereas the inputs can only have a certain set of characters. Delta is the transition function. Q0 is the initial state of the machine. And F is a set of acceptable final states of the machine. With NFA, you can have missing edges on the graph that are assumed to fall into a rejection state. So let's look at an example. So for A star, B star, C star, you can have any number of A's, any number of B's, and any number of C's in order, including 0. So we'll start at Q0 and look at the input values over here. Let's start with the correct one. Q0, and we go from A to A, and maybe over here to A. That's part of what makes it a non-deterministic finite automation, is because there's no set determinants of it moving on this route of A or on this route of A. It could take either path. Next, it would take B, and then maybe B over here. And then this would take C, and C again. And you can see that the double circle indicates a final accepted state. So for the incorrect one, you maybe have A, and then take B over here. But there's nowhere from A to go. This would actually fall into one of those unseen paths that leads to a final rejection zone. This is what makes non-deterministic finite automation non-deterministic. So what's the difference between NFA and DFA? There are only a few. A DFA has all possible edges shown, so there's none of those missing edges that will lead to rejection. You can see all of the edges in a DFA. As well, an input state can only have one outcome. So there's only one path every input state can possibly take. This means if you input the same string multiple times, you'll have the same output every time. So you can see a DFA is a little more complicated, but it's also much easier to read because you don't have any missing edges. And there's only one path for each input string. So let's try the correct input string. So we start Q0, which is the initial state, and we would follow A, and A, and A one more time. The next path would take us across to B, to the next state. The next letter is a B, which will keep us going, and then a C, which will move us over to Q2. And then one more C at the end will keep us at Q2 for a final accepted state. If we do the incorrect string, you can see how it'll end up at Q3, the only not accepted final state. So we start at Q0 and we'll follow A and A again. Now we follow B over. Now at Q1, if you insert an A, which is the next character, it'll move you over to Q3, a non-accepted state, which falls into a loop. Any letter you put in between its A, B, or C will loop back to itself and be a non-accepted state. So you can see that with C, C, and B, the final three letters of the string. Here's my resources page. I hope you enjoyed. Thank you very much.